Here are a few examples of identifying the transformations and the properties we just talked about in the equations from actual equations. So let's look at number one. Number one, we have y equals -2, parentheses, x plus 3 cubed minus 6. So the question here for all of these 1 through 6 is, number one, what format are they in? Which form? And what can we tell from each form? So number one is in transformation or vertex form. Transformation or vertex form. So since it is in transformation or vertex form, we can actually tell the vertex. And remember, the vertex is HK. H is whatever the opposite of this value is. So it's +3, so our H is -3. K is the exact same as the sign in front of it, so the K is -6. So I know that my vertex is at -3, -6. Now what does that tell me? Well, that tells me that this function is going to be different from the parent function of f of x equals x cubed, because now this function, because of the -3 for the x coordinate, is going to move to the left 3 units, and because of the -6 for the y value, it is going to move down 6 units. Because the a is negative, that is a -2. That indicates, because of the a value, that this is going to be reflected. So those are the things that I can tell. Now, my a value is greater than 0 here. Also, when my a value is greater than 0, that means that my function is going to be stretched. And it's going to be stretched vertically. That means that you're going to take it and you're going to stretch it vertically. It's going to get longer and thinner vertically. That's a stretch. So now let's look at number 2. Number 2, y equals 8x cubed plus 3x squared minus 6x plus 7. That is standard form. And remember, your d value, which is your constant in standard form, is your y-intercept. So from this, I can tell that my y-intercept is 7. So let's look at number 3. Number 3, y equals 1/2 times the factors x plus 6, x minus 4, and x plus 3. That is intercept form. And remember, from intercept form, we can tell what the 3, 2, or 1, depends on what we have, what the x-intercepts are going to be for our function. So looking at these factors, since I have x plus 6, that means one of my intercepts is going to be -6. I have x minus 4, so that's going to be 4. And I have x plus 3, so that's -3. My p value is -6, my q value is 4, my r value is -3. Those are the 3 places on the graph that my cubic will intersect the x-axis. So let's look at number 4. Number 4 has -x cubed minus 2. Now, while it's missing an x squared term and an x term like number 2, this is still considered standard form. It's not factored like in number 3, and we don't have anything designated in parentheses like we do in number 1. So again, from standard form, you don't necessarily always have a b term and a c term, but we still have our d term. So I know on the graph that is going to be my y-intercept. And so that's what I can determine from number 4. Number 5, we're back to transformation form. We have 5 times x minus 1 cubed plus 12. So that is transformation vertex form. And remember, we can identify our vertex, which is our HK. H, remember, is the opposite of what's inside, so it's x minus h, so that means h is +1. And remember, K is the same as the sign on the outside, so it's +12. So what that tells me is this form, this particular cubic, is going to move to the right 1 unit because of the positive 1, and it's going to move up 12 units because of the 12. Additionally, my A value is 5. Now, since it's positive, there is no reflection. There is no reflection. However, it is greater than 1. Okay? So with my A value being greater than 1, what that's going to do is that is going to stretch my function vertically. It's going to narrow and stretch up and down. Okay? My last one is also transformation form. Okay? So the question is with this one, what is the difference with what I have? Okay? Now, I originally said transformation form, and I notice there's a typo on the paper. When you look at this, you've got negative 4x times x minus 10 squared. This is not in transformation form. Why is it not in transformation form? If you look at transformation form, it's already set up to where we have our exponent of 3. It's cubed. This is not. We have an x pulled out in this particular one. So we have several options here. We can't do anything from this form, so we can either convert it to intercept form or we can convert it to standard form. And for this particular purpose, intercept form would be easiest. I'm going to take that negative 4x and leave it. That's one of my factors. Okay. I'm then going to take x minus 10 squared, and I'm going to write it as x minus 10 times x minus 10. Now I have 3 factors. This x is actually a factor in itself as well. When you have an x as a factor in intercept form, that is the same thing as having an x minus 0. We just don't have to write the minus 0. If it helps you out, you can go ahead and write it that way. And so I'll write this as x minus 0 instead of x times x minus 10 times x minus 10. Now I have intercept form, and I can determine my 3 roots. So my 3 roots are going to be 0, 10, and 10. So you can write the 10 twice, but it's really not necessary. Okay. So talking about that, coming down here to the behavior of our functions, let's look at this. If a is greater than 0, which means a is positive, if a is positive, okay, the function is going to be positive, and it is going to increase. That means it's increasing as you move to the right. So it'll look something like this. Okay? So it increases as you go left to right. That's a positive function. Now, if we have a is less than 0, that means that the a value is negative. Then that means that the function is negative, and it is going to decrease. That's what creates the reflection. So instead of going left to right all the way up, I'm going to go left to right down this way. It's going to be a reflection because now I'm decreasing as I go left to right.